In the RMDS coronavirus project, we aim to create an end-to-end data science solution to help guide global response to the spread of COVID-19. RMDS embraces our unique ecosystem approach, collaborating with data scientists, engineers, epidemiologists, and researchers from organizations worldwide, including Wuhan University, Harvard Dataverse, amongst other groups. Currently, there are two main components we're working on. One is to build up a dashboard that displays an up-to-date status of coronavirus breakout. Specifically, we include an interactive global map of how many cases in each place and where they are. It is interactive, so you can hover over or click on each area to show further information, including historical trend, related news report, social media trends, and policies implemented. This is easier for our users, tech or non-tech people, to check information that has been well organized. We're trying to make it a comprehensive public portal that everyone can easily keep up to date. The second part is an alert system. By doing this, we can track and predict the spreading trend of the virus in certain areas. Currently, we have developed two data-driven models. A time series LSMT model, which rely on historical number of cases and other factors that have a potential impact on this issue to predict future trends, and an epidemiological SIR model to simulate the spread of the virus in different cities to predict how long the virus would affect people's life. For the future, we want to set some threshold criteria and try to send out an alert if there is a high level of risk for some certain places like restaurants, retail shops, etc., to warn people as well as the business owners to be prepared. So data is the foundation of whatever data science projects. Thanks to the RMDS ecosystem approach, we are to be in partnership with Wuhan University. Our teammates who are in the epidemic center worked very hard to assess different types of data on the ground, some of which are even confidential. Also, we have Harvard Dataverse program providing technical advice to make better data models. What's more, RMDS ecosystem has one of the largest and ever-increasing data and AI community. We can source from a large talent pool to work with top analysts, data engineers, data scientists, software engineers, biologists, epidemiologists, and dataset providers to give a thorough evaluation from different aspects of the public crisis, which makes ours more comprehensive than any other known projects. With the variety and high volume of data, along with advanced data analysis models, now we get pretty good accuracy of following and predicting the trend in most cities in China. A lot of the good results should be attributed to the talented data scientists and subject domain experts in our team that help with model development and feature selection. There are differences among different countries, the law, the culture, the environment, and many more. But by creating an alert system with recommended resources and a call for action, we hope to positively impact the individuals members in our global community. They can understand not just the status quo, but also how much efforts they need to take to protect themselves in the upcoming weeks. We also provide a high-level look at the spread of the disease, including which countries are of high risk, when the disease's inflection point would be, which government policies are the most effective, and how the government can utilize data and AI to restore stability and minimize economic loss. Using classic algorithms to recognize the RNA sequence may be prohibitively time-consuming, as the coronavirus genome is one of the longest among all RNA viruses, reaching 30,000 bases. Deep learning algorithms are much more adept at such large-scale parallel repetitive calculations. The Baidu and Alibaba, the pioneer cloud computing companies, have opened their research platforms to accelerate testing the gene of the virus. The cloud arm of the China's e-commerce giant has already broken the world record for high-precision whole genome sequencing, doing in 15 minutes what it used to take scientists 120 hours. It is expected that this can continue to accelerate research and prediction on the COVID-19 RNA structure. Many countries have already been in the stage of testing COVID-19 vaccine. It is hoped to achieve safety approval within 90 days.